Now I'll show you the importance of being sealed, with apologies to Oscar Wilde. Let's have cooked food implement IEquatable of cooked food. And I'll have Visual Studio implement the interface. Now for food, I argued that this was a bad move, because the only workable logic you could put in the interface equals method was to call objects.equals. But for cooked food, I can put the equals logic in the interface method, like this. The reason this works for cooked food is that cooked food is sealed. That means the only non-null thing that can ever be passed to this method is a cooked food instance. So this method can cope with anything that's passed to it. Because the type is sealed, inheritance is no longer an issue, and we can have equality and type safety working together. And you can get that to work. And you can do the same thing in the cooked food equality and inequality operators if you want. Avoid having them call into the object_static_equals method. But remember, that will only work because cooked food is sealed. You can't do anything like this with the unsealed food class. So, is implementing IEquatable of t for sealed classes worth it? Well, you can gain a tiny bit of performance by implementing IEquatable of t. In fact, string, a sealed class, is an example of a class that does implement this interface. Personally, though, I would hesitate about doing it in my classes. You make your sealed classes more complicated, and you have to remember separately that you're implementing equality one way for sealed types, and a different way for unsealed types, and of course it's different again for value types. And you've seen how disastrous the results can be if you don't get everything exactly right. For me, I want to write robust code as efficiently as I can, and I don't think that giving myself loads of fiddly things to have to remember is a good way to do that. But your mileage or your situation may be different, and implementing IEquatable of t for a sealed class is a valid solution.